this bob about axis passing through point P and also about axis passing through point 2. What is the speed of that? Let V be the speed. I'll give this also. And let's try to find out this in vector form so that it'll be easier. And this is a string. First about O. What is that axis? About O, parallel to y-axis. About O passing through y-axis it is. How much angular momentum? L-O y. I'm writing clearly. Just do make observation. This should be equal to how much? mv m into r bar. R bar will be r minus I cap cross v k cap. I cross k cross I will be g. I cross k I'm asking, so minus j. So this will be everything will become vr j cap. I think it's justified, no? How that angular momentum will be directed along positive y-axis. You try to put fingers at r bar. V bar, angle between V bar and R bar will be perpendicular. The diagram I'm unable to show that. Please do have imagination. These two will be perpendicular. V bar will be out of the plane. I'm unable to show that. Okay, some. I think this will be not correct, no? So you'll get confused. That's why I'm showing it here like this. So here you write it strictly. V bar perpendicular to R bar. At all points it will be. And now I want about axis passing through point P. So LP, don't say any axis here, just about an axis passing through point P. And what is the basic formula? This is making an angle theta. So we should define that L bar, no? So M into L bar cross V bar. So let's define that L bar. If the length of string they given, that one, if they give this distance y, then in terms of that also can express. So we know, let me define L bar. What is L bar? L bar we define minus L sine theta I cap minus L cos theta j cap cross V k cap. I cross k. K cross I cross k will be minus j, no? Minus of minus j. This will be mvl sine theta j cap. Keep it here. This. Then now j cross k will be minus I. So this will be minus mvl cos theta I cap. So what is the resultant? This will be mvl minus cos theta I cap this is the axis. The angular momentum will be directed like this. Sir, is it about x, y or z axis? Look at the L bar, how it will be directed. Minus I cap plus j cap. Minus I cap plus j cap. So where that L bar will be somewhere directed in this direction. There's a very important fundamental problem, not like a numerical. It's not a numerical, so it's a very generalized theoretical idea. Now you see that one. So what should be the L bar about P? How it will be directed? It will be directed in this direction. So I'll put the direction somewhere here. Now let's calculate magnitude. How much magnitude? How much of magnitude? Will be MVL only. Will be MVL only, magnitude. But what about direction? Sir, is it always like this? No. When the same bob comes to this position, I'll show in the next diagram. So here the magnitude is constant, but the direction will be continuously varying here. So I'll put, this is a very basic problem which will help us a lot in going for next complicated objects when we go for the different shaped objects here. When Bob is here, how L bar, and when Bob is here, we have to show L bar. There is a position 1, position 2. So here it will have velocity V, here it will have velocity V like this. Tangential, there is a point 2. Now, how the direction of first at 1, how L bar will be directed somewhere here. When it is at 2 Bob, the L bar will be directed like this. Like that, what happened to that L bar? L bar vector is going to rotate. It's going to rotate here. It'll be like this. So if this is the axis, so it's going to rotate here. Look at thumb will not rotate about y-axis. It will make some angle. Able to see this? It'll be like this. Huh? It will not be one direction. Somewhere it'll be like this here. Then again at some position it'll be like this. So it'll be like this one. The thumb, this particular, or look at this face. Don't rotate about this one, or I think I can show better from here like this. So this L bar vector will be rotating here now. Here it will be like this. The tip of that will be rotating here. So I think you can just do one thing. Take some stick, something, put a bob or something, some eraser, something, you fix it, Favquick will be there. And here what happen, you just put one match stick, you take it and put it here. And as you start swinging, no, this will rotate. Here also what happen, this L bar vector will make a small cone. It will make a small cone. So to understand you, I'm drawing like this. So where the tip of that angular momentum vector will be, it will be rotating in a circular path. So what should be the radius of circular path? It all depends on the magnitude. And also we have to predict that angle. Angle depends upon theta. Fine. This is like a, so what we can conclude here. Magnitude is constant. Constant, but direction changes. Direction will be continuously be changing here. In fact, L1 equal to L2. Only at 2 positions I'm showing it here. Got this? So I think now it's a unlimited topic here, no? I can ask you anything. So you go for circular motion, you go for laws of motion, wherever you want, you step up. You'll get so many moving objects. For all that moving objects, try to think about angular momentum. Fan rotating, what the angular momentum of this? Door, you open door, close door, how the angular momentum will be that? Anywhere you see just an object swinging or rotating, you just go and make observation how the angle